Lesson 14.4 is finding integral from given areas. This time we're really going to focus on some properties of integrals that you need to know. So the directions say that the regions A, B, C, and D in the figure below are bounded by the graph and the x-axis, and the areas in the enclosed regions are labeled in their figure with the respective numerical values. Find each value. So this is saying find the area of the function from 2 to -2. What I want you to notice is this is not in the right order. You always want a smaller number, saying we're going from this number to the bigger number. We're reading it x values of left to right, not backwards. So what I want you to know to do is to switch it. So I'm going to switch and put -2 first to 2 f of x dx. But if I switch the order, it's actually going to negate the value that I get. And so in this case, if I'm going -2 to 2, I'm going to have this area and also this area. I'm not using these or these. So I would have a -6. I'll put it down here. -6 and then +3, because it's above the x-axis. That equals -3. But I'm going to have to make my answer be the opposite of that, or negate it, which would make it turn into 3. Okay, you could also, I guess, look at it in this problem as saying, well, now this is going to become +6, and this is going to become -3. 6 minus 3 makes 3. But in problems where they don't give you the values, just know that you swap the numbers, the x's, and make it negative. All right, number 2 is having a number times the function. So what I need you to know that you can do is actually take that multiple, that number out in front, and say it's going to be 1/2 times the integral from -2 to 3 f of x dx. And so if we're going from -2 to 3, we're going to need this area of 4 and this one of 10, which it'll be negative. And so we would have 4 minus 10, but then I'm going to take half of that. So that would be half of -6, which is -3. What I also want you to know is anytime we have a function times a half, what that does is vertically compresses it by half. So really, instead of this being up here at 3, it would be half of that, which would put it like 1.5. And half of this one at -5 would be like -2.5. Oop, I went a little far. So it's really taking half of 10 and now making this an area of 5, and half of 4 now making this an area of 2. Well, 2 minus 5 makes -3. So I'm hoping all of this makes sense with what we know about functions. Okay, we've got a couple more. Number 3, we have our f of x function, then -2. So what I want you to know is you can split this up into 2 different integrals. First one, let's say from -8 to 6 of f of x dx. And then we'll say we could either do plus -2 or minus. I'll do plus, and I'll have the same integral of -8 to 6, and I'll have the -2 dx. So what I would want to do is first find the area of this. So -8 plus 6, or not plus 6, or -8 to 6. So I want this area, this area, this area, and this area. Okay, I want to talk about actually what happens when you have a function -2. So let's say we were to have the function x squared, which is a quadratic, a parabola shaped like this. Usually then the parent is here at the origin. But if I were to make it -2, that's going to shift it down 2 units and now put the vertex here instead. So what we're doing is we're taking this whole thing and shifting it down 2 units. So imagine this being down 2, and this being down 2, and this being down 2, like right here, down 2, down 2. So now my curve would be doing something. Let's see, so I've got down 2. I'm going to make an imaginary line here, see if I can draw this. So I'm trying to make it mirror what it is, just shifting it down to. Okay, and I only need to go to 6, so I'll stop there. So what I need you to realize is this area is still going to be the same. That's still going to be 4. This is still going to be 13. That's still going to be 10, and that's still going to be 11, but now more of it's going to be down below, and it's actually going to make a rectangle here. So we need to figure out the area of this rectangle in here. That's what is changing. So what I want you to think of is you're just finding the area of f of x like normal. So that was going to be 4, which is negative, plus 13 plus 10 minus 11. But then we're going to have to also add the rectangle to it, which since we went down 2, we know that's a height of 2 and a length of, we're going from -8 to 6. Well, that's 6 minus -8. That should be 14 units long. So we'll have 2 times 14. But since I'm down below, that's going to be a negative. So the net area here would be, let's see, 13 plus 10 is 23. 23 minus 15, that's 8. Just got my 9, 10, 19. Minus 11. Okay, and then the rectangle is now going to take away 28 units. So it's taking away 28 because now we're below the x-axis there, and so that would be -20 is what that would net. If this were a plus, you would do the exact same thing and have a rectangle above the x-axis, and you would have this being positive, and you would add it. So it's adding that much more to it. Okay, so this property doesn't help us a whole lot. We just need to know, shifting it up or down, we're going to add or subtract a rectangle from our net area. And it's always going to be how far it spans for the x's and then what it went up or down. All right, number 4 has absolute value. Remember, absolute value changes things because it makes stuff positive. So in this function, we're just basically taking absolute value of the whole thing. So we would do from -3 to 5. That would be this area, and this area. So we've got -3 plus 8 minus 10, and then we're going to take absolute value. So that would be 5 minus 10 would be -5, which would turn into an area of 5. But I want to look at what I put on number 5. It's the exact same problem, and we're going to use the same graph, but now the absolute value is only around the function. When a function is absolute value, it means it changes everything and it reflects it over the x-axis. So this being an area of -3 down here is now going to come up here and be +3. And this area here of -10, because this is at what, 3, -6, now it's going to be at 3, +6. It's taking each y value and making it positive, is now going to be +10. So in this problem, it's different because now I'm just having 3 plus 8 plus 10, which is 21. I get a different answer, a completely different answer than how I did number 4. So it depends on if the absolute value is around the whole thing. You do it normal and then take the absolute value. If the absolute value is already just around f of x, then you have to just add all the absolute values of those areas. Number 6, we've got an integral where it says from -7 to -4. That area is 8. And then from -4 to -2, that area is -3. What is the value from -7 to -2? So what we'll get used to seeing is they won't give us the area, but they'll give us maybe something like this, and we have to find it. And so it puts the pieces together, saying if I want to find the area from -7 to -2 of f of x dx, that's going to equal the area from -7 to -4, because these are both x-intercepts, and we're finding area made with the x-axis. So I would go from -7 to -4, and add to that the area. I would pick back up at -4, and then go to x is -2. And so that means that this area was 8 plus this area was -3. That gives me a net area of 5. So it's a simple property that really we've already been doing. And last but not least, find all x-intercepts be for which -5 to some value, that area needs to equal 0. So we need to net nothing. We need the same area to cancel out. So looking at -5 would be here. I could say that B is also -5. If I wanted to find the area of x is -5 to x is -5, I would be having no area at all. So one answer is always going to be that same A value. So I could go from here to here and I would have nothing. The other option is to get something to cancel out. So if this is +6 area and this is -6 area, I could say that from x size of -5 to -1, that would also make an area of nothing. But nothing else is going to net out. So that's my only two options. So you're going to have to put both those answers in.